In the previous video we looked at this HP3570A 3330B Automatic Synthesizer, which is basically a sine wave generator that's able to sweep frequency and amplitude. And although that can be used standalone, this 3570A network analyzer is nearly always used in conjunction with one of these, or a 3320, I think, another model of this. But so I don't think this can run standalone, but this can, and I have no interest in this really. So all I'm going to do here, I haven't even turned it on, all I'm going to do here is just a teardown. Let's just have a look and see what's inside of it, and maybe it'll be a good source of spares for Hewlett-Packard gear of this era, e.g. for that. Anyway, let's have a look inside. Similar deal with the other guy, just 4 screws there. I've also taken the 2 off for this, so you can have a look at the display, which seems to be the same sort of displays as in the 3330, so yeah, plenty of good spares there. And lifting the lid, again, it looks like the 3330 with lots of boards inside. Well, it does seem to have a lot more in the digital section than in the analog section. I assume that's digital, it was in the other one. And power supply's got a nice big cover over it. So yeah, let's lift these shields and look at a few boards. Lots of adjustment points all over the place, and the screws are all out so we can lift these shields. And looks like we've got some thermal insulation going on there. I wonder how they come out. Oh no, they're fixed, right? So beautiful little boards. Again, like the 3330, there's every board in the analog section has its own compartment shielded by this U-shaped aluminium that extrusions which slide together and lock together. So these three I presume are the same. I don't know what these things are, but they look like they need to be kept insulated. So I won't do that one. We'll start from the front for the rest. Okay, this one's got a... that was coming loose, so that would have been a fault if I needed to use this thing. Just a RCA connector. Those things are, yeah, transformers of some sort with ferrite slugs in them. Trim pots, big fat resistors. And you've seen those. Similar. Look like relays. Reed relays. So this machine seems to have even more boards in it than the 3330B. That's an interesting chip. Bit of unobtainium, no doubt. Next shield. Start from the back this time. Lots of adjustments on this guy. And as you can see, lots of gold plated goodness, typical of Hewlett-Packard from this era. Even the motherboard down there is gold plated. More reed relays. Slide switch. Like the 3330, all these little boards make it very easy to troubleshoot, especially if you have a extender to put in there. Unfortunately, it doesn't come with a spare one. You have to find one from somewhere, but that would make it easy to troubleshoot. And the motherboard at the bottom, if we took the bottom off, the bottom cover off, would be covered with signal names built into the PCB. So very easy to troubleshoot from the bottom as well. And lots and lots of test points. Look at all the test points on there. You see them? Zillions of test points there. Crystal. Looks like a 11.82 megahertz crystal. Each little board with its own solid aluminium compartment. No wonder it weighs a lot. This one's probably about 20 kilos, a bit lighter than the 3330. There's another air veined trimmer capacitor. And third shield, more temperature ice. I'll find out what these things are from a manual. What are they? Just resistors, precision wire wound resistors. But, well, yeah, I think they are. I think they're, or maybe inductors. Yeah. Okay, we might be repeating ourselves here. Yeah, this looks to be identical. Two channels here. Of course, it's got two channels, so we don't need to look at the rest of these. They're just like those. This one had one extra board there. The rest here are the same, but that one's extra. And the difference across these two rows is these two digital boards, by the look of it, more digital boards. Lots of transistors. This one's got a ribbon cable going to more digital stuff. A couple of fuse sockets that aren't used. I'm sorry, that was for the cable. These two aren't used. Big chip is a 74154. What's that? One of 16 decoder, I think. Moving to the digital section. Even the boards have, even the cover rather, has labelling for each of the boards. ASCII output, that's this guy. A PROM, probably. A few socketed chips with HP part numbers, so I don't know what they are. That was the ASCII encoder, ASCII output rather. This is the BIDEC register. So this is probably like the 3330 and it's got a built-in digital computer. I'm trying to find some dates on this stuff. It looks to be 1982 when this was made, but probably designed 10 years earlier, like the 3330 was. Input buffer isolator. Oops, that breaks something. Again, more socketed chips. I feel like I'm busting these things. This is address rec, whatever that means. Some chips are from 80 and 81, but the latest ones are 82. this clock. Shouldn't that have a crystal on it if it's the clock? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, yeah. A32 clock. Okay. A clock without a crystal. Yep, this is a computer because this board is the ALU, Arithmetic Logic Unit. Although doesn't seem to be much on there. Carry, that's the ALU. So this is a digital computer. It'll be like the 3330, it'll be a bit serial rather than parallel, so you don't see things like a 74181 Arithmetic Logic Unit chip. It's all done serially. Some of these are hard to get out. These cables along here don't help. This is the delay, limit and offset. This digital stuff's not as interesting as the analog gear, is it? But ROM control number 2. Oh, no cable, that's nice, isn't it? Another 74154. And presumably ROMs. 82S126F. Some Signetics part. One-time programmable ROMs. This is ROM control number 2. This one does have a cable. Sorry, ROM control number 1 this is. Again ROMs, but for some reason this one needs a cable. And the last of the computer boards. This is the timing. Again, no crystal on the timing board. One board left under the power supply, and there's warnings about bad voltages even when it powers up. Legend for the test points and adjustments. And there's a board there. Let's get him out. And a BNC socket on the power supply regulator board. Why would that be? And in fact the 3330 had a built-in BNC socket named Logic Probe, not on a board, just on part of the chassis. I'm not sure where that goes, but interesting also. But I think I read on EEV blog about someone having trouble with this transistor here. And just coming back to these things with the foam over them, when I pulled out the boards before I just saw some shiny cylindrical thing and I thought there might be cans like an electrolytic capacitor, maybe some oven controlled crystal oscillator or something, but if we get these out of the way, we find that these can lift up fairly easily. And we've got a tube down there. So let's get him out. There we go. And an octal, old-fashioned octal base. And they're not electron tubes, they're Midland Ross crystals, or crystal filters. I haven't been able to find any information about these. Midland Ross apparently went out of business in 1986, I think, a few years after this was made. This is marked 99.9885 kilohertz, so pretty low frequency. That's why it's so big. You know, you can't get a frequency crystal that low in the normal small packages. It's fairly high precision too, down to tenths of a hertz. And yeah, so there's 3 of those. I'm not sure they're all the same frequency. Look at the next one. 99.9985 kilohertz, I think that was the same. And of course the ones on the far side should be identical. Now why has this one got something in the top of it? Doesn't on the far side. Oh, it's a spare digit for the front panel display. That's nice, isn't it? I wonder if that's factory provided. Ah, get out, you bastard! And the third one, 99.9985 kilohertz again. So yeah, all three are the same frequency. And here's the relevant part of the schematic. This here's that little board, and these are the two crystals down here. Zooming in a little bit. The board and two crystals for each channel. So does that mean there's two in each of those tubes? I'm not sure, because there's there's three of these boards and three of these tubes. So is there two crystals in each tube? Not sure. Can't find the information on the Midland Ross devices. Crystal filter, is that different to a crystal, or is it just the way it's used? I'm not sure. And the other unusual item in these two channels with this Hewlett-Packard unobtainium chip, which appears to be a log amplifier, hybrid log amplifier. There's a schematic for the board. This guy appears to be the hybrid log amplifier. And one last part to check is those resistors or inductors here. No, they're reed relays. How come I've only got two terminals? Oh yes, two posts down there going into the coil, and the reed is the outside too. Okay, that explains that. So there you have it, a quick teardown of an HP3570A network analyzer. A lot of spare parts and a lot of gold. Yeah, I can't see myself trying to make this thing do anything useful, so I will probably scrap it for the gold. I know some people will think that's criminal, but oh well, what else is going to happen to it? I won't be able to get as much money for it as the gold is worth, probably, so yeah. Anyway, I'll leave it as it is for now. I won't do the gold thing unless I get desperate, or the price of gold goes up a heap. Well, there you have it. Hope you enjoyed. Catch you later.